All right, guys. Well, this keep getting better and better. I feel better, but this project, hopefully, one day I'm able to do really tapping on the machine. And today I came out with a little idea, which is, like I said on the previous videos, I got a final control here on this sharp machine, and that one uses a M29 code on that final control. So it's an M code. So M codes, they activate stuff, like you can run those codes. So what I did is hopefully I don't shake too much and you can see what I'm talking about. You remember I said I was running a speed control mode, a speed enable, which is the same speed control mode, and then reverse it if I'm going back. That is one of the speed control mode if you're gonna use 0 to 10 volts. So you have to go a speed enable, and if you want to go reverse, you have to apply power to that. You have to ground that common power, that common input. I'm sorry, and reverse the spindle. So, that's the way to reverse it if you apply in 0 to 10 volt. Now what I'm doing, I'm enabling speed, but I'm using this orthogonal external pulses, which is a step in direction coming from the Z-axis that I overlaid, or I don't know how you say that, overlay the outputs from the spindle over to the Z-axis also, and I'm using that axis to output my step in direction to the spindle drive. So if we go back over here, we can see that we got a speed enable right here, and where we got a speed enable, we just got emergency. If you're gonna use step in direction, or what you do, you just enable the speed the same way you enable speed here, but you don't need to reverse it, because you do got to reverse it here when you're 0 to 10 volt, because you're only going one way, 0 to 10 volt. If you will be using plus minus 10 volt, then you wouldn't need to reverse it, because the minus will reverse it and the plus will do it forward. In this case, since we're using a step in direction, we only need to enable the speed and just send plus and minor inputs of pulses, and that will create our speed, whatever speed we need. So that's what I'm using right now. I'm using a speed control mode to run my spindle when I'm cutting apart. That's why I said, but I do need the best positioning control mode if I'm gonna do a thread, So if I'm really gonna gear my spindle to my Z-axis, which is not ready yet, but it's working better for this idea I came out now. So I'm using, like I said, spindle speed control mode to cut parts, like with an M mill or whatever, milling stuff. But if I'm gonna thread, I can with this. I thought about the M code, the M29, and since this is what I was using before, and I don't want to change my maximum speed, the speed on positioning control mode, remember, like I told you, comes from the factory set up to 1000 RPM, and I don't want to go higher than that, because that's the reason you see 2 drives over there, because I burned that one down and I have to buy another one. So I don't want to do that. But I do want to use that feature, which is a very good positioning control mode coming out of the control board to the spindle. Is definitely just like the any axis. It's just right there, angle by angle. So what I did, since I wanted to use positioning control mode only when I'm threading, I put this output. I put all of this information, not all of this, because all of this is already done into the drive, but I'm trying to turn this on only when I'm threading. So what I did, I don't know if you see that over there, that output number 8 is already on, and it's on because I was just running the code. I was testing, I was taking a shower. I said, wait a minute, let me go over there and try that, and that's what I did. I wired this wire right here, this orange white. That's positioning. That will enable positioning control mode. See right there, position enable. That's orange and white. That would enable my positioning control mode. On my speed control mode, my enable is the blue and white. So blue and white is a speed mode, and orange and white is a positioning mode. So I'm running on speed mode when I'm milling, and I want to run on positioning when I'm threading, which is pretty nice feature on this drive, and I never thought I could use them both at the same time. But I came here, wired this up, and it works. So I made that I will show you what I did now on an M29, and hope you can get this information. So again, a speed control mode for milling, and positioning control mode for threading. It's not ready yet, but I'll show you how I control that, and it's pretty simple. That output, so I can turn. There's a lot more things to be put into the M code that I could be using. I'm gonna try to seat you over there. Hopefully you see what I'm talking about. So this is the same code that I was using yesterday, last night, or whatever. If you see right here, let me look, see if you can see. Let me put it down a little bit, better angle. Okay, so right here, you see I'm on G90, X -1, Y0, M3. So I am turning my M3, honestly, just for Mac to know which way I'm going. I don't know if I still can go away without that. I don't believe I do, but I just left it over there. I have my M8, which is my coolant on, but I deleted from here. We don't want coolant while we're doing this. And what I did, you see, I got an M29 over there. I got an M29 S150. I put that over there. I didn't post it on Bobcat or nothing. I just put it over there. What I figure is, on my posting, I might try to show you that later. On my posting, you can control all of these like switches, where you want the M29 or the G90 84 or G95, if you want this to be a 99 instead of a 95. So what I found out after a little bit of testing a little bit ago is you can either have the 95 on a line by itself before you start the threading, or you can have it right on the line after the G84. It works on Mac. Maybe on other machines it don't work, or maybe it would work better if we put it before. For now, it's doing the same thing for me, so I want to show you that. So you see, I got an M29, and the reason I got the M29 over there is M29 is just turning on my output over there. Pretty much, I'm mechanically, if I can say it like that, not by software. Yes, I'm using the software, but I'm mechanically turning a relay to switch my spindle from speed to positioning control mode. Let me close this, and let me call my VBS script editor, and I'll show you. Let me see, M29. See, I created the M29 here. Hopefully you can see it. The M29 here, and I got an M19. I also created that one. That's what orientate my spindle, whatever. So I'm gonna open that. You see, really simple. It's just a sub main, activate output 8. So pretty much anytime I run my M29, I'm activating that output number 8. Hope you can see it over there. Maybe better. Yeah. So that's it. My M29 just activate output 8. This is just for testing. This may not work for you, and I don't believe it will, because I believe I'm gonna have to put a little bit more stuff into this code in order to get it right, in order to I'm probably gonna have to put some conditions here for this to happen the right way, and not, you know, crash the machine or whatever. Because remember this, when I'm going to M29, which is my positioning control mode, I'm only turning 1000 RPM maximum speed. It don't matter how many pulses I can put into this, the drive. The drive is not gonna go higher than 1000. So no, I don't want to change this. I'm gonna reset so my output A goes off. I'm probably gonna have to put some kind of another M code, or just an output, or I mean use an input to reset that M29 after the threading is done. Or I can just make another M code to cancel that process on, or right on software, which I can put it on the, I believe we can put it on the posting already, and anytime we do a threading, it's gonna do that. Remember guys, I'm not sure this is gonna work. I'm just trying my best to, and just, you know, just to learn, because I believe this is the only way we can do it. So right now I'm gonna pull the G code again. See, I put my M29 over there and my S150. I don't have any speed here. I'm not controlling any speed up here like you used to, because before I have my S100 over here, or 150 or whatever up there, and that's how the software was getting the information to turn at 100 RPM, and then do a G8495. Come on. So what I did, I put my M29 over there and it works good. The only difference you're gonna see is how quick my spindle, it will turn on and off, and how fast it will stop and start. Like if you look in the previous video, it wasn't doing that. It was kind of just slowing down and then, you know, and then stopping. And right now it will just stop, like, you know, like a really hard stop. And you can even hear the motor doing a little bit of humming when it's braking, you know, when it's being brake or DC powered by the drive or whatever they call it. So I'm gonna save it. Let me see, M29, 15, yeah, 13, yeah, save this code. Let me go get a light so you can see it. Now I warned you, let's see. This is it's even missing more. I don't know if you remember yesterday when I was showing here that my RPM in my feed it will be off sometime. Now since the spindle is coming, I mean it's starting on and off kind of harder or faster, I believe the software is even losing more of that feedback from the index input, and kind of missing even more on my feed when it's trying to do the G95. So, but I just want you to see that, and I'm gonna give you a reason why that's happening now, which I already got a video on it, and that's what I believe so far. I'm not sure, but that's what I believe. So we're gonna reset, and I'm gonna move you down here. Let's see what I'm talking about. I just want you to focus on the tool, the holder, and see how fast it will stop. And I'm gonna try the same both ways. I'm gonna try with the M29 and just with an M3 and 4, and you will see. Let me run it. Let's see what happens. See that stop? That's position control mode. See over there, it messed it pretty bad. My G95 messed up over there. Bad. I'm gonna try to sit you in here, see if you can get even better view of what's going on. Let's see. I got you there. Okay, let's run it again. Right. Well, I hope you got that. And you can see how good the spindle is stopping and all that. That's because we're doing position and control mode. So now, what I'm gonna do, I'm gonna reset here, so we turn off our M29. When we do that, our M29 is gonna go off. I'm gonna pull out the code again. What I'm gonna delete this M29, and I'm just gonna put my M3. Oh my God! Come on, I just like it like that. M3 over there. I left it up there, so I will leave it still work. So now, since I just put M3 on it, my spindle is gonna run on speed control mode, not on position and control mode. You're gonna see my M29 code is not gonna work because I'm not calling it over there. So let me save it and run it. Wait, if I don't reset, I won't run. See the difference on the stop? Kind of wiggles a little bit. That's the speed control mode. All right, so you see the difference on how the spindle comes on and off, and I'm gonna bring you back here. I'll show you that. Well, you know that my M29 is not on right there. See, it's not on because we didn't call for it. We were just using speed control mode out of the relay. So we were enabling the speed control, and our step in direction was just controlling the drive, and that's how we did the last time. So the concept of using an M code like any other, well, not like any other, like many machines out there, is using an M29, an M code, to call an output, which I believe you can just create any M code you want. In this case, I'm using M29 because a lot of people use it for threading, and it's, you know, the concept is kind of working. Now I'm gonna tell you what I believe is my biggest problem, and I'm gonna do that. Let's see how I do that. I got a video on this already. I hope you can get this. I had a video on this. I went and got this washer just to show you what I'm talking about. I already got a video on how the UC300 will pick up index from and send it over to Mac. So what I figured is this, and I'm gonna show you what I'm talking about right here. So I'm gonna close this code, and I'm gonna call an M3 S100, and I'm gonna enter that. So you will see we got right at 100 and hope you can see it, 103 RPMs right there. It's close, and you can see our spindle moving around 100 RPM. And we can even come back here and check that we are running, because I can come to the drive and just hit this button right here, and that's my spindle RPM, my actual RPM, 103 revolutions per minute. Pretty much like the software is picking up. And I don't know if you can see that light over there blinking. That light is my index pulse coming from my index sensor. But what happened with that is, and I'm about to show you right now. So you see, we got input. We got the same speed we got on Mac. It's the same speed we got on the software. But check this out. I'm gonna call another S. Let's just say I'm gonna slow the spindle. I'm gonna do an S80. Wait a minute. S80. Enter. See, we'll still get S79, S80. The spindle is even slower. And I'm gonna call again S50. We still got input over there, and our spindle is still slow. S30. See right there the problem? No RPMs, 0. I had no feedback, no index pulse coming to Mac, and my spindle's moving. So I should be able to have something telling Mac, hey, I'm moving, I'm turning, right? And I'm gonna come to the drive and show you this. Guys, this is really important. This messed up a lot of things. You see? 27 RPM. I called for 30, I got 27. So the drive it won't lie to me. The drive is just perfect. This is hooked up to the encoder on the back of the motor. This is, a servo motor. So whatever is there is whatever the motor is spinning. And this is really important. I already got a video on this, and it's kind of, you know, it kind of kicked my ass on this. Honestly, it did. Why? So you saw over there, my spindle is moving, and I'm not even showing RPM on my index. I'm gonna turn it up a little bit. I'm gonna turn it up to, let's say, 40. So S40. Let's see if we got something. Not yet, nothing. We're gonna do, come on, S45. Enter. Nothing. So S47. See, as soon as we hit 47, we start counting 52, 51. Right? See right there? 52, 51. And if I back up again, it's 45, just for saying. Let's see what happens. Nothing, it's gone. So what happened over there is, and the reason I say this is because I've seen a lot of videos on indexing with Mach3. I don't know on your setup, but on this one I have never been able to do 1 pulse per revolution like they call on many of the, not the videos, because you know we are all, come on, we are learning. I don't know shit about this. I'm just learning. What happened is, I'm right now, Mac called for 1 pulse per revolution. So Mac is trying to get that pulse, 1 pulse per revolution, and that's what they call, that's what they told you, that's all you can send to it. And right now I'm gonna tell you this. Right now I'm gonna pull my UC300 setup, and I show you what I'm talking about. So you see my index, pre-scale. My pre-scale means how much I'm getting, how many pulses I'm getting from my spindle being sent to the UC300, and the UC300 is translating it to 1 pulse per revolution on Mac. The problem with that is the UC300 right now is getting 4 pulses, but they're so slow that it's not able to tell Mac, listen, this is the speed I'm doing. The way I found to fix this, and I'm gonna show you 4 pulses why. On top of the spindle, I got a nut that holds my my spindle bearing, and that nut is I don't know the name of those. No, they got different notches on it, and the nut over there has got 4 notches, and I got a Hall sensor, you know, a proximity sensor reading on those 4 notches, and that's how I'm getting my RPMs, and that's how you see that. Why I got 4 pulses set up on UC300 is because I got 4 pulses sent from that sensor over to the UC300, and the UC300 is telling the software I'm doing, you know, whatever RPMs, because I'm translated those 4 pulses. But on the other video I got before, you can see that I'm able to send, the more pulses I send over to the UC300, the better accurate my speed is going to be at low RPM. I see a lot of videos over there indexing on Mac, but they're running 1,000 RPM. That's what they're only able to pick up on 1 pulse per revolution. So right now we are able to read as low as, let me just turn it up here. See, as soon as I hit over there 10%, we're going like 50. I start reading on 53 RPM. If I go low again, no more RPM. That means if I would have, instead of 4 pulses, I will have maybe 6 or 5. I will still have RPM over there, being able even to go lower than 50 or lower than 45. I will still have RPM. So the point here is, you see how slow my spindle is coming up and down on when I'm trying to thread? What happened is Mac is not being able to pick up that input that the spindle is turning until we hit like 50 RPMs. I hope you understand this. my G95 code, my G95 is not picking up signal until my spindle is already running 50 RPM. And it shouldn't be like that. If we are running 1000 RPM or 1 RPM, our software is supposed to know anytime how you know how many RPM we're doing per minute, how many revolutions per minute we're doing. So I believe my biggest problem on threading right now is basic on this. I'm only picking up 4 pulses per revolution, and I will only pick up pulses if I'm going higher than 47 revolutions per minute, and that is because I don't have enough pulses going to the UC300 on every revolution. On that other video, I'm gonna say it again, that I did before, that the video I think is called Mach3 closed loop, or I don't know, I forgot. I always forget those stuff. I'm running a Fanuc motor on this machine, and that Fanuc motor has 128 pulses per revolution on the encoder, on the back of the motor, and it just worked perfect. 128 pulses, and even more, let's just say on the Cincinnati right there, the Cincinnati over there, it also got the same controller. It's got Mach3 and the UC300 down there in servo, and that motor over there, that Fanuc motor over there, it has 256 pulses per revolution, so it's twice what the Fanuc had on it, and that one works perfect. I can get every revolution per minute, even 1 revolution per minute. It will be sent to Mac if I just put it here on the plug-in control. Come on. No. If I come to setup, you can just type in how many pulses per revolution you're gonna pick up from the encoder, and the UC300 is gonna be able to translate that and send it over to Mac. The more pulses you got a limit, because let's just say right here, let me try to do it for you. Right here, I'm only, come on, okay. I'm only able to put like 3 decimals over there. So, you know, I can put 999 is the maximum I can put. I wish I can put 1024, which is what I got on the encoder on the back of this motor. That would be beautiful, but I can only put 999. So right now I got 999. That's the biggest number I can put on my encoder, on my pre-scale from the UC300, 999. And you know, it really don't work for me having a, so I gotta put a 4. That's all I'm picking up from it, and just close it. We'll be back on it. All right, well, I hope you got the idea. The more pulses you can send to the UC300, the better your software is gonna know how fast you're going. And I believe my problem right now is that. My problem is I'm not picking up enough pulses from my, pulses from my spindle revolutions. And so my software is not able to know what it is. And it is spinning right now. You can see it, it's been moving since I've been talking. And it's not showing any RPMs over there. As soon as I just override it a little bit, see, 52 RPM. Because I override it, it's probably turning, now it's turning 52 RPM for sure. So lower than that, it will not pick it up. Let me see if I try something. What if okay, I'm gonna try this. So I'm gonna reset it to 45 RPM. Or revolutions, and I'm gonna come to my plugin here, and I'm gonna put me a 3. Let's just try that. Let's just lie to the software. I'm gonna put me a 3. And let me okay this. Nah, it don't work. Not enough RPMs. me just put me in. Let me put me a 1 over there. Let's see what I'll do. No, still nothing. So you see, we gotta have enough. We gotta have enough speed, as enough pulses coming from the index pulses. So come on, put me a 4 back on it so I don't forget it. Close it. Yeah, 4 because I'm picking up 4 RPMs. All right, guys. Well, I hope you like this. So we proved that we can use the M29 in position and control mode if we're gonna do threading, and that's the idea. It's cold. I'm going inside, and I hope you like it. My next move is gonna be, I'm either gonna make me another knot so I can put on my spindle to pick up a little more pulses, a little more, you know, it's gonna have more gaps or grooves on it, so I can pick more pulses per revolution. So if I'm running 4, I can pull that knot out and just make some notches on it with a wheel grinder or whatever. Yeah. And just try that out. So I can probably do, if I do 8, it'll probably do a lot better. But the deal is that I believe we are not able to do the threading perfect, and that's how our feed is not getting right on time, because we are not reading RPM right from the beginning. So there's a delay before we get feedback from our index. So the software is doing the best it can, and besides, this is not a super fast computer. Maybe that's another deal. So I believe that's what's happening. Almost positive. We are not getting full feedback from our index, and then our C-axis start moving, and it's not letting the software calculate how fast it's supposed to go, and it's picking it up right on the middle of the process. That's what sometimes we stay instead of going to the full feed, we're going halfway of the speed. Sometimes we're going 90% of the speed we're supposed to be feeding at on the C, and that's what I think the problem is it lays at. So all right, well guys, thank you so much. I appreciate you watching the videos and all that. If you got any comments, please, or help, any ideas, I will appreciate it. There's a lot of people out there with a lot of knowledge on this, and I like to know if somebody has tried something, whatever. Nothing sounds crazy for me, honestly. Whatever you have tried, I like to know and see. So if you don't tell me, whatever you believe on how have you tried it, or if you messed up, I'm gonna have to do it myself, and then I'm gonna be spending time here for no reason if I got somebody over there that can give me a hand. All right, guys. Well, thank you very much. Have a good night, and I hope you enjoyed this video. And if you got any questions, let me know. Thank you so much.